Hey guys, you are officially done with our graphing videos. In this video, what we're going to talk about is average versus instantaneous velocity. By the end of the video, you will be able to differentiate between average and instantaneous velocity. So let's go ahead and do that. Average velocity is going to be your total displacement over your total time. So when you're finding that mathematically, what you'll say is that your average velocity, which we call V bar, is your final position, so S final, minus your initial position, S initial, divided by your total time. So T final minus T initial. And that's how we're going to find our average velocity. Our instantaneous velocity, on the other hand, is going to be our velocity at any given point in time. So for a nice graph that is shaped like this, or a graph that's shaped like this, or a graph that's shaped like this, it's really easy to figure out your instantaneous velocity because it's in fact the same as your average velocity. But when we have some slightly more complicated graphs, like that, it's a little bit more complicated. So in this video, what we're going to talk about is how to find your average and instantaneous velocity from our more complicated graphs, like the one on the following slide. So let's look at an example of a slightly more complex graph. So here, again, my time is on the x-axis and my position is on the y-axis, and I've got my curve of position versus time. And as before, the slope of my graph is equal to my velocity. However, unlike previous problems, the slope of your graph is not constant here. So what we're going to do is we're going to talk about how to figure out the slope at different points in a curved graph like this one. And actually, it's a pretty straightforward process. However, it's something that I find challenging, not because the math is hard, but because I have a lot of trouble drawing straight lines. So you're going to definitely want to practice your skill at drawing straight lines, because your instantaneous velocity, your instantaneous speed, is going to be the slope of a line tangent to the graph, so slope of tangent line at whatever point in time, so at given time. So we have our time halfway through our journey. We have our time about a quarter of the way through the journey at the beginning of the journey, 3/4 of the way through our journey, and about at the end of our journey. And my speed is going to be and so to figure out my speed, I'm going to draw tangent lines to each of these points. So when I say a tangent line, what I mean is that my line should only intersect with the graph at that point. So only intersects with graph at given point. So let's go ahead and see how well I can draw these. And again, this is something that I have a lot of trouble with. So you may also struggle if drawing straight lines is not your strongest suit. So let's go ahead and see how we do. So here is my approximate tangent, and I'm going to go ahead and just move it a little closer at my first point. And I could do the same at my 1/4 way point, like so. And again, your lines should be a little neater than mine. This is something that I have a hard time doing on a screen. Let's go ahead and do our halfway point, our 3/4 point, and at the very end of my graph. So now I'm ready to answer these questions. So my instantaneous speed halfway through the journey is going to be the slope of this line at the halfway point. And this is a nice flat line, so it's going to have a slope of 0. So V1/2, my speed halfway through the journey, is going to be 0 meters per second. Next, I want to figure out where I'm moving the fastest. So what I want to do is I want to find the line with the largest, or the point with the tangent line that has the steepest slope. So I want to find the steepest tangent. And in this case, I actually have two possible choices because the beginning of my journey and the end of my journey have tangent lines that have the same magnitude of slope. So they're equally steep. It's just that they're going in opposite directions. So one is going uphill, the other is going downhill. So I'm moving the fastest at the very beginning, and at the very end of my journey. Finally, I'm asked to find my average velocity. So again, my average velocity, V bar, is going to be my final position over my final time, so S final minus S initial, over my final time minus my initial time, so my change in position over my change in time total. And what is important to recognize here is that I am starting at 0, 0, and I'm ending at some time t 0. So my final position is 0, and my initial position is 0. And I can see that because they both are on the x-axis of my graph. My final time is some random number, and my initial time is 0. And which gives me a fraction of 0 over t. And because the top of my fraction, the numerator of my fraction is 0, my average velocity will also be 0. Because 0 divided by anything is still 0. So there you have it, guys. We have solved all three parts of this problem. So let's talk takeaways. First of all, your average velocity is your total displacement divided by your total time, while your instantaneous velocity is your velocity at a given point in time. And the way that we're going to find the instantaneous velocity is the gradient of the tangent line at that given point in time. So at given point in time. And finally, both your average velocity and your instantaneous velocity are useful to know depending on your situation. So for example, somebody who is running a marathon likely really cares more about their average velocity because they want to know how quickly they'll complete the marathon. They don't care quite as much about which parts of the marathon they're running more quickly in and which parts they're running more slowly in. Your instantaneous velocity, on the other hand, might be useful in a situation like driving down the highway, where you're going to care more about how quickly you're going at any given moment than you will about how quickly you went overall. So if I'm driving from my house to Mount Vernon High School, I don't really care about how quickly I went overall. What I care about is how fast was I driving the speed limit in the road by my house that has a 25 mile per hour speed limit, and was I driving the speed limit on Route 1, which is much, much faster. So again, both values are useful depending on your situation. So you guys have learned about average and instantaneous velocity, and you know how to figure out your velocity when you have a slightly more complicated graph than just a straight line. So go ahead and see if you can do this on your own. Best of luck and happy solving.